More than 3,000 years ago, the ancient Egyptians braided fibers to make stronger, longer-lasting materials. Today, a small company in Cincinnati, Ohio, is braiding materials for the same reasons. What began with candle wicks and developing the equipment to make them has filtered into many other areas, even aerospace. Over the years, A&P Technology Incorporated has been designing and creating materials for many applications such as sporting equipment, prosthetic devices, and furniture. In 2001, A&P partnered with NASA's Glenn Research Center through the Small Business Innovation Research, or SBIR program. Their goal was to develop a new braided material for jet engine fan cases. If the engine's rotating parts, particularly fan blades, fail, the enclosing shrouds, particularly fan cases, play a critical role.
It's important to contain the debris or the fragments when you have a failed part like that, a blade, a blade, either a fan blade, compressor blade, or turbine blade. And if those blades would happen to break off, you want to be sure that you can safely contain the debris or the fragments inside the engine so they don't pose a threat to either to the other parts of the airplane or obviously to the passengers of the airplane.
For stronger yet lighter fan cases, the team wanted to use composite materials, which makes the braiding process trickier.
Composite reinforcement yarns are typically very fragile, and so we had to modify the equipment to handle much more delicate, fragile yarns. There's a whole variety of techniques associated with bringing together large numbers of fibers to make larger structures as opposed to the commercially available equipment.
One of the main reasons A&P products are unique lies with their highly specialized braiding machines, often designed and built by the firm to meet customer needs, such as NASA's.
They were able to adapt a braiding process and a braiding machine that could make carbon fiber braid without damaging the fibers, and to make it into a specific braid architecture that proved to be particularly impact resistant when it went into a composite structure.
Working with engine manufacturers GE, Honeywell, and Williams, A&P and NASA designed, manufactured, and tested fan case prototypes for 3 different sizes of engines. Because the testing has been so successful and the braided composite technology is now being certified by the FAA for new engine fan cases, these materials will undoubtedly be used elsewhere on planes.
The more we learn about how these types of materials and structures perform, the more we think we can adapt them to other applications that would have a huge weight savings benefit.
It bodes very well for other applications, particularly since we've been able to demonstrate to the FAA as well as the customers that the material is repeatable and can meet a whole variety of requirements.
And perhaps even to components for space exploration.
We've worked on a couple of inflatable material applications, notably an airlock that we worked with the NASA Johnson Center.
The Egyptians and NASA. Stronger, more lightweight materials from braiding.